welcome to our physics class, the topic of magnetism, and it's a continuation of what we have already looked at the properties of a magnet. And specifically, in the fourth one, we were looking at the magnetic field patterns, and I really wanted to do it on the board so that we can see how magnetic field patterns are formed. But before we start with the magnetic field patterns, I would first want to say that the following is what we look at when we are marking the magnetic field patterns. Number one, the magnetic field pattern should run from north to south. Anytime you draw a pattern, you should always make sure that it goes from north to south. Something else. A pattern is complete with an arrow, and in case you draw it as a line, it becomes incomplete. Why? Magnetic field patterns, as we are going to see later in Form 4 and Form 3, they are types of vector quantities. And as you know, vector quantities are like scalar quantities. They have a magnitude and a direction. Therefore, anytime you draw a magnetic field pattern, you must make sure that the pattern has an arrow. Finally, the magnetic field pattern should always leave the magnet at 90 degrees. As much as they appear curved in other types of, in some diagrams, they always leave the surface at 90. And when they come to join the surface of the South Pole, they should join it at 90 degrees. Finally, another property of magnetic field pattern is that the magnetic field patterns do not cross. In case they cross, then that question is deemed as wrong. I'm going to have some examples, and I will try quite a number. I'm going to start with a bar magnet and see how the magnetic field patterns are formed around it. This is a bar magnet. By now, we have looked at different types of magnets. Let me start with the bar magnet and how we draw its magnetic field patterns. Remember, we say the patterns always run from north to south. So I begin by drawing them on both sides. Next, there are some patterns that will run from north to any other pole on this side, and there is another magnetic field pattern that arrives from a foreign pole into the South Pole. Drawing it that way, it's correct because number one, I have not crossed my magnetic field patterns. Number two, they are all running from north to south, and if you look at one of the pattern, it is leaving the surface at 90 degrees. This is the field pattern of a bar magnet. Next, we look at another type of a magnet. The U-shaped magnet, also called the horseshoe magnet. They tend to have a similar shape because, just like the name suggests, it has a kind of a U. The poles are found at this region, and I remember I had given you a diagram in our previous lesson of a U-shaped magnet. It was bright, and I had given it as an example. So when I come to draw the magnetic field patterns, I'm still going to use the rules that the patterns should always run from north to south pole. Some will also move here. Another thing, some of these will go to a foreign pole, that's the south pole. Others will originate from a foreign pole into the south pole. And having drawn that, you have drawn the magnetic field patterns of a U-shaped magnet. Finally, we look at what happens if I place some magnetic materials or non-magnetic materials at the center of two magnets. So I start by placing a soft iron between a north and a south. This is a trick that is used by examiners where they know that most of the students, they know the shape of a soft iron is round. However, we know that for the soft iron, this is a magnetic material. However, for plastic, it's not a magnetic material. And we want to see what is the difference between the pattern here and the pattern that is formed here. Let me start with the top one, where we have a soft iron which is magnetic in between the two poles. So the magnetic field will run into the soft iron and out, and it is going to run on both ends. And at the center here, it creates a region that we call a magnetically shielded region. As the magnetic field patterns are running from north to south, they create a magnetically shielded region here. What about for the case of a plastic between north and south? Since this is a non-magnetic material, what happens? The magnetic fields run as if nothing is between these two poles. So the same applies when we have air. For example, I have a north pole next to a south pole, and since air is a poor conductor it's a non-magnetic material, the magnetic fields will pass straight from north to south. So that's the difference between placing a magnetic material and a non-magnetic material. In our next session, we are going to look at something small of what happens if you place two light poles together. And we're going to see where repulsion, when you're looking at the laws of magnetism, we talked of repelling, a light poles repel, and want to see what happens when you have two light poles repelling. So thank you for watching and stay tuned for the next class.